AWK is an interpreted programming language designed for text processing and typically used as a data extraction and reporting tool. It is a standard feature of most Unix-like operating systems. AWK was very popular in the late 1970s and 1980s, but from the 1990s has not retained its level of awareness in light of newer languages like Perl, upon which AWK had a strong influence. AWK was created at Bell Labs in the 1970s, and its name is derived from the family names of its authors Alfred Aho, Peter Weinberger, and Brian Kernighan. The acronym is pronounced the same as the name of the bird, AWK. When written in all lowercase letters, as AWK, it refers to the Unix or Plan 9 program that runs scripts written in the AWK programming language. The AWK language is a data-driven scripting language consisting of a set of actions to be taken against streams of textual data either run directly on files or used as part of a pipeline for purposes of extracting or transforming text, such as producing formatted reports. The language extensively uses the string data type, associative arrays, and regular expressions. While AWK has a limited intended application domain, and was especially designed to support one-liner programs, the language is Turing-complete, and even the early Bell Labs users of AWK often wrote well-structured large AWK programs. History: AWK was initially developed in 1977, then significantly revised and expanded in 1985–88, resulting in AWK and the free GNU AWK implementation. The revision of AWK coincided with the development of Perl, and in the 1990s Perl became very popular, largely replacing AWK in the niche of Unix text processing languages. AWK remains in some use, and is also of continuing interest as an archetypal example of the data-driven programming paradigm. As one of the early tools to appear in version 7 Unix, AWK gained popularity as a way to add computational features to a Unix pipeline besides the Bourne shell, the only scripting language available in a standard Unix environment. It is one of the mandatory utilities of the single Unix specification, and is required by the Linux Standard Base specification. AWK was preceded by SED. Both of them were designed for text processing. They share the line-oriented, data-driven paradigm, and are particularly suited to writing one-liner programs, due to the implicit main loop and current line variables. SED is significantly simpler, while AWK can be seen as extending the same approach. AWK was an important inspiration for Perl, which is in turn a more complex and multi-paradigm programming language, but allows the same data-driven programming as in AWK. The power and terseness of early AWK programs are notably the powerful regular expression handling and concision due to implicit variables, which facilitate one-liners together with the limitations of AWK at the time, were important inspirations for Larry Wall when developing Perl. Structure of AWK programs. AWK is a language for processing text files. A file is treated as a sequence of records, and by default each line is a record. Each line is broken up into a sequence of fields, so we can think of the first word in a line as the first field, the second word as the second field, and so on. An AWK program is of a sequence of pattern action statements. AWK reads the input a line at a time. A line is scanned for each pattern in the program, and for each pattern that matches, the associated action is executed. Alfred Aho. An AWK program is a series of pattern action pairs, written as, where condition is typically an expression and action is a series of commands. The inputs is split into records, where by default records are separated by new line characters so that the inputs is split into lines. The program tests each record against each of the conditions in turn, and executes the action for each expression that is true. Either the condition or the action may be omitted. The condition defaults to matching every record. The default action is to print the record. This is the same pattern action structure as SED. In addition to a simple AWK expression, such as foo1 or, the condition can be begin or end, causing the action to be executed before or after all records have been read, or pattern 1, pattern 2, which matches the range of records starting with a record that matches pattern 1 up to and including the record that matches pattern 2 before again trying to match against pattern 1 on future lines. In addition to normal arithmetic and logical operators, Awk expressions include the tilde operator, which matches a regular expression against a string. As handy syntactic sugar, without using the tilde operator matches against the current record. This syntax derives from sed, which in turn inherited it from the ed editor, where slash is used for searching. This syntax of using slashes as delimiters for regular expressions was subsequently adopted by Perl and ECMAScript, and is now quite common. The tilde operator was also adopted by Perl, but has not seen as wide use. Awk commands. Awk commands are the statements that are substituted for action in the examples above. Awk commands can include function calls, variable assignments, calculations, or any combination thereof. Awk contains built-in support for many functions. Many more are provided by the various flavors of Awk. Also, some flavors support the inclusion of dynamically linked libraries, which can also provide more functions. For brevity, the enclosing curly braces will be omitted from these examples. The print command. The print command is used to output text. The output text is always terminated with a predefined string called the output record separator whose default value is a new line. The simplest form of this command is print. This displays the contents of the current record. In Awk, records are broken down into fields, and these can be displayed separately. Print $1 displays the first field of the current record, print $1, $3 displays the first and third fields of the current record, separated by a predefined string called the output field separator whose default value is a single space character. Although these fields may bear resemblance to variables, they actually refer to the fields of the current record. A special case, $0, refers to the entire record. In fact, the commands print and print $0 are identical in functionality. The print command can also display the results of calculations and/or function calls. Output may be sent to a file or through a pipe. Built-in variables. Awk's built-in variables include the field variables, $1, $2, $3, and so on. They hold the text or values in the individual text fields in a record. Other variables include, nr keeps a current count of the number of input records. nf keeps a count of the number of fields in an input record. The last field in the input record can be designated by $nf. File name contains the name of the current input file. fs contains the field separator character used to divide fields on the input record. The default, white space, includes any space and tab characters. fs can be reassigned to another character to change the field separator. rs stores the current record separator character. Since, by default, an input line is the input record, the default record separator character is a new line. OFS stores the output field separator, which separates the fields when awk prints them. The default is a space character. ORS stores the output record separator, which separates the output records when awk prints them. The default is a new line character. OFMT stores the format for numeric output. The default format is %.6g. Variables and syntax. Variable names can use any of the characters, AZARZO-9, with the exception of language keywords. The operators +/ represent addition, subtraction, multiplication, and division, respectively. For string concatenation, simply place two variables next to each other. It is optional to use a space in between if string constants are involved, but two variable names placed adjacent to each other require a space in between. Double quotes delimit string constants. Statements need not end with semicolons. Finally, comments can be added to programs by using as the first character on a line. User-defined functions, in a format similar to C, function definitions consist of the keyword function, the function name, argument names and the function body. Here is an example of a function. This statement can be invoked as follows. Functions can have variables that are in the local scope. The names of these are added to the end of the argument list, though values for these should be omitted when calling the function. It is convention to add some white space in the argument list before the local variables, to indicate where the parameters end and the local variables begin. Sample applications. Hello World. Here is the customary Hello World program written in awk. Note that an explicit exit statement is not needed here. Since the only pattern is begin, no command line arguments are processed. Print lines longer than 80 characters, print all lines longer than 80 characters. Note that the default action is to print the current line. Print a count of words, count words in the input, and print the number of lines, words, and characters. As there is no pattern for the first line of the program, every line of input matches by default, so the increment actions are executed for every line. Note that W plus equals NF is shorthand for W equals W plus NF. Some last word. S is incremented by the numeric value of $NF, which is the last word on the line as defined by awk's field separator, by default white space. NF is the number of fields in the current line, for example 4. Since $4 is the value of the fourth field, $NF is the value of the last field in the line regardless of how many fields this line has, or whether it has more or fewer fields than surrounding lines. Dollar is actually a unary operator with the highest operator precedence. If the line has no fields, then NF is 0. $0 is the whole line, which in this case is empty apart from possible white space, and so has the numeric value 0. At the end of the input the END pattern matches, so S is printed. However, since there may have been no lines of input at all, in which case no value has ever been assigned to S, it will by default be an empty string. Adding 0 to a variable is an awk idiom for coercing it from a string to a numeric value. With the coercion the program prints 0 on an empty input, without it an empty line is printed. Match a range of input lines. The yes command repeatedly prints its argument on a line. In this case, we tell the command to print the word Wikipedia. The action statement prints each line numbered. The printf function emulates the standard cprintf, and works similarly to the print command described above. The pattern to match, however, works as follows. NR is the number of records, typically lines of input. Awk has so far read, that is the current line number, starting at 1 for the first line of input. % is the modulo operator. NRA% for 1 is true for the first, 5th, 9th, etc. lines of input. Likewise, NRA% for 3 is true for the 3rd, 7th, 11th, etc. lines of input. The range pattern is false until the first part matches, on line 1, and then remains true up to and including when the second part matches, on line 3. It then stays false until the first part matches again on line 5. The said command is used to print the first 7 lines, to prevent yes running forever. It is equivalent to head N7 if the head command is available. Or just add. If exit after the print statement. The first part of a range pattern being constantly true, for example 1, can be used to start the range at the beginning of input. Similarly, if the second part is constantly false, for example 0, the range continues until the end of input. Prints lines of input from the first line matching the regular expression, cut here, $, that is, a line containing only the phrase, cut here, to the end. Calculate word frequencies. Word frequency uses associative arrays. The begin block sets the field separator to any sequence of non-alphabetic characters. Note that separators can be regular expressions. After that, we get to a bare action, which performs the action on every input line. In this case, for every field on the line, we add 1 to the number of times that word, first converted to lowercase, appears. Finally, in the END block, we print the words with their frequencies. The line 4 creates a loop that goes through the array words, setting I to each subscript of the array. This is different from most languages, where such a loop goes through each value in the array. The loop thus prints out each word followed by its frequency count. Toloa was an addition to the one true awk made after the book was published. Match pattern from command line. This program can be represented in several ways. The first one uses the Bourne shell to make a shell script that does everything. It is the shortest of these methods. The $ pattern in the awk command is not protected by single quotes so that the shell does expand the variable, but it needs to be put in double quotes to properly handle patterns containing spaces. A pattern by itself in the usual way checks to see if the whole line matches. File name contains the current file name. Awk has no explicit concatenation operator. Two adjacent strings concatenate them. $0 expands to the original unchanged input line. There are alternate ways of writing this. This shell script accesses the environment directly from within awk. This is a shell script that uses environ, an array introduced in a newer version of the one true awk after the book was published. The subscript of environ is the name of an environment variable. Its result is the variable's value. This is like the getenv function in various standard libraries and POSIX. The shell script makes an environment variable pattern containing the first argument, then drops that argument and has awk look for the pattern in each file. Checks to see if its left operand matches its right operand. Is its inverse? Note that a regular expression is just a string and can be stored in variables. The next way uses command line variable assignment, in which an argument to awk can be seen as an assignment to a variable. Or you can use the vvar equals value command line option. Finally, this is written in pure awk, without help from a shell or without the need to know too much about the implementation of the awk script, but is a bit lengthy. The begin is necessary not only to extract the first argument, but also to prevent it from being interpreted as a file name after the begin block ends. ARGC, the number of arguments, is always guaranteed to be a permil 1 yen, as ARGV, 0, is the name of the command that executed the script, most often the string awk. Also note that ARGV, ARGC is the empty string. Initiates a comment that expands to the end of the line. Note the if block. Awk only checks to see if it should read from standard input before it runs the command. This means that awkprog only works because the fact that there are no file names is only checked before prog is run. If you explicitly set ARGC to 1 so that there are no arguments, awk will simply quit because it feels there are no more input files. Therefore, you need to explicitly say to read from standard input with a special file name. Self-contained awk scripts. On Unix-like operating systems, self-contained awk scripts can be constructed using the shebang syntax. For example, a script called hello awk that prints the string hello, world, may be built by creating a file named hello awk containing the following lines. The f tells awk that the argument that follows is the file to read the awk program from, and the same flag is used in sed. Both these programs default to executing a program given as a command line argument, rather than a separate file since they are often used for one-liners though most other interpreted languages default to reading a program from a file. Versions and implementations. Awk was originally written in 1977, and distributed with version 7 Unix. In 1985 its authors started expanding the language, most significantly by adding user-defined functions. The language is described in the book The AWK Programming Language, published 1988, and its implementation was made available in releases of Unix System V. To avoid confusion with the incompatible older version, this version was sometimes called New AWK, or NAWK. This implementation was released under a free software license in 1996, and is still maintained by Brian Kernighan. Old versions of Unix, such as Unix/32V, included AWK, which converted AWK to C. Kernighan wrote a program to turn AWK into C++. Its state is not known. BWK AWK or NAWK refers to the version by Brian Kernighan. It has been dubbed the one true AWK, because of the use of the term in association with the book that originally described the language and the fact that Kernighan was one of the original authors of AWK. FreeBSD refers to this version as one true AWK. This version also has features not in the book, such as Toloa and Environ that are explained above. See the fixes file in the source archive for details. This version is used by, for example, FreeBSD, NetBSD, OpenBSD and OS X. AWK is another free software implementation and the only implementation that makes serious progress implementing internationalization and localization and TCP/IP networking. It was written before the original implementation became freely available. It includes its own debugger, and its profiler enables the user to make measured performance enhancements to a script, and it also enables the user to extend functionality via shared libraries. Linux distributions are mostly GNU software, and so they include AWK. FreeBSD before version 5.0 also included AWK version 3.0, but subsequent versions of FreeBSD use BWK AWK to avoid the more restrictive GNU General Public License as well as for its technical characteristics. MAWK is a very fast AWK implementation by Mike Brennan based on a bytecode interpreter. libmawk is a fork of MAWK, allowing applications to embed multiple parallel instances of AWK interpreters. Orca is another translator of AWK scripts into C code. When compiled, statically including the author's libAWK, the resulting executables are considerably sped up and, according to the author's tests, compare very well with other versions of AWK, Perl, or TCL. Small scripts will turn into programs of 160 to 170 kilobytes. Talk is an AWK compiler for Solaris, DOS, OS/2, and Windows, previously sold by Thompson Automation Software. Jawk is a project to implement AWK in Java, hosted on SourceForge. Extensions to the language are added to provide access to Java features within AWK scripts. Jawk is a modern implementation of AWK in the Perl programming language, hosted on CPAN. It supports ranges, indexing columns by negative numbers, a Perl mode, and more. XGAWK is a fork of AWK that extends AWK with dynamically loadable libraries. The XMGAWK extension was integrated into the official GNU AWK release 4.1.0. QSEAWK is an embedded AWK interpreter implementation included in the QSE library that provides embedding application programming interface for C and C++. BusyBox includes a sparsely documented AWK implementation that appears to be complete, written by Dmitry Zakharov. This is a very small implementation suitable for embedded systems. Books: Aho, Alfred 5. Kernighan, Brian W. Weinberger, Peter J. The AWK Programming Language. New York, New York, Addison Wesley. ISBN A0-201-07981-X. Retrieved April 16, 2009. The book's webpage includes downloads of the current implementation of AWK and links to others. Robbins, Arnold. Effective AWK Programming. Sebastopol, California, O'Reilly Media. ISBN A0-596-00070-7. Retrieved April 16, 2009. Doherty, Dale. Robbins, Arnold Said and AWK. Sebastopol, California, O'Reilly Media. ISBN A1-56592-225-5. Retrieved April 16, 2009. Robbins, Arnold. Effective AWK Programming, A User's Guide for New AWK. Bloomington, Indiana, iUniverse. ISBN A0-595-10034-1. Archived from the original on April 12, 2009. Retrieved April 16, 2009. Arnold Robbins maintained the GNU AWK implementation of AWK for more than 10 years. The free GNU AWK manual was also published by O'Reilly in May 2001. Free download of this manual is possible through the following book references. See also, Data Transformation, Event-Driven Programming, List of Unix Programs, Procedural Programming, SED, References. Further reading, Hamilton, Naomi. The AZ of Programming Languages, AWK. Computer World. Retrieved April 16, 2009. AAA Euro interview with Alfred Aho on AWK. Robbins, Daniel. AWK by Example, Part 1, An Intro to the Great Language with a Strange Name. Common Threads. IBM Developer Works. Retrieved April 16, 2009. Robbins, Daniel. AWK by Example, Part 2, records, loops, and arrays. Common threads. IBM Developer Works. Retrieved April 16, 2009. Robbins, Daniel. Awk by example, Part 3, String Functions and Checkbooks. Common threads. IBM Developer Works. Archived from the original on May 19, 2009. Retrieved April 16, 2009. Awk Euro Become an expert in 60 minutes. Awk, a pattern scanning and processing language. Euro a commands and utilities reference, the single Unix a registered trademark specification, issue 7 from the Open Group, GAWK, 1, Euro a Linux user commands manual, GoKinit, TCP/IP Internetworking with GAWK, external links, The Amazing Awk Assembler by Henry Spencer. Awk Community Portal, Awk on flossmanuals.net, Awk DMOZ, Git repository of the direct lineage of the original Awk source code.